Have you ever seen the value of pi in a triangle? I mean, pi is the ratio that the circumference turns into the diameter. So naturally it would be in there. Track with me. This is a 45-degree triangle with a 1-inch hypotenuse. Whenever that is, the adjacent and opposite are equal to 0.707, 106, 78, 12. Let's take a look at a 1-inch diameter circle. At 45 degrees, the height is equal to 0.707, 106, 78, 12. This is the length that creates the triangle, as you can see right here. Because whenever we look at a 1-inch circumference ball, at 60 degrees, the circumference of the ball is 0.8660254,038 inches. The circumference of the ball at 45 degrees is 0.707, and the circumference of the ball at 30 degrees is 0.5 inches. So whenever the ball is amplified by the value of pi, the circumferences, the curve turns into the diameters of the ball. 360 divided by pi might be degrees per inch on the 1-inch diameter circle, but that's also the formula of creating another diameter. You see, whenever we're finding the degrees of a circle, we're finding the original 3.6-inch circle. Pick a diameter of circle and label the heights. Now, whenever you multiply the main diameter by pi, it'll obviously tell you where 360 degrees is. When you multiply the 60-degree height by pi, it'll tell you where 311.76914 degrees is. 45 will tell you where 254.55 degrees is. And the 30-degree height will tell you where 180 degrees is on your main circle. Now label a 3.6-inch circle, and you'll see that the inside heights mirror these degrees, and that's because there's an original 3.6-inch circumference ball. In the 3.6-inch ball, pi is the value of the circumference at 60 degrees. And it's also equal to the length of the equilateral triangle that's inside every circle. And that is why dividing the circle is dividing the equilateral triangle. So whenever you solve a triangle using sine and cosine, you're using the original 1-inch diameter circle or the 1-inch radius circle. But whenever you use the Pythagorean theorem and you're using squares, those squares are actually linked back to the original 3.6-inch circumference circle, where the diameter and the equilateral triangle height reciprocate one another to equal 1. So this is true pi in a triangle, and these measurements can also represent circumferences and degrees. 1.8 squared plus pi squared equals 3.6 squared.